Section 5.4, Dividing Polynomials. We're going to be using the division algorithm quite a bit, and this algorithm states that given a polynomial function dividend, f of x, and a non-zero polynomial divisor, d of x, where the degree of d of x is less than or equal to the degree of f of x, there exists unique polynomials q and r such that f of x equals d times q plus r. This actually works with constants as well. If you take a number, say 40, and we want to divide it by 7. All right? Well, that's my divisor. Okay, my divisor is 7. The quotient here, the result is 5. There's my divisor, there's my quotient, there's my original constant, plus my remainder. 7 times 5 is 35, so this is 7 times 5 plus 5. We're doing the same idea, except we are dealing with polynomials. Now this is very useful in that it tells us often either if something factors, okay, if it factors, which then tells us solutions to equations, as we'll see later, or it shows us that if it's rational, then there might be an asymptote. Okay, so if that remainder is 0, then that means that the divisor divides evenly into f of x. So consider 40 divided by 8. The remainder is 5 with a remainder of 0. Okay, in that case, it factors in that way. So we'll go ahead and do long division for a few of these. And for some special cases, we actually are going to talk about synthetic division here in a little bit, and then an application problem. So if I want to divide 5x squared plus 3x minus 2, I want to divide this by x plus 1. So what it comes down to is looking at the leading terms here. So I have x and I have 5x squared. X times what would give me a 5x squared? What do I need to multiply? Well, a 5x. Okay, so 5x. Now I'm going to multiply 5x times x plus 1. So 5x times x is 5x squared. 5x times 1 is 5x. And just like in standard division, I'm going to take that away. I'm going to subtract that and see what remains. 3x minus 5x would be negative 2x. Be very careful with the signs there. And then we'll bring down a minus 2. Now I ask my question again. X times what would give me a negative 2x? And the answer is negative 2. I'll put a minus 2 here, then I'll multiply minus 2 times x plus 1, which is minus 2x minus 2. Subtracting those two, I get 0. My remainder equals 0. That's fantastic. That means that what I could have done, I'm going to write this in the way the division algorithm works, 5x squared plus 3x minus 2 can be written as x plus 1 times 5x minus 2. That means that could have factored, which then dividing by x plus 1 on both sides tells us what we actually wanted. 5x squared plus 3x minus 2 divided by x plus 1 is 5x minus 2, which is the answer to the question we were asking. So this case where the remainder is 0 is going to come out to be very, very useful as we progress through this chapter. All right, next we will divide 6x cubed plus 11x squared minus 31x plus 15 by 3x minus 2. Minus 31x plus 15, and our divisor is 3x minus 2. So the question first is 3x times what would give me a 6x cubed? And that would be a 2x squared. Because a squared times an x squared times an x is going to be an x cubed. So multiplying that would be a 6x cubed, like we planned it to be. 2x squared times negative 2 is minus 4x squared. Then we will subtract those two terms. Again, be very careful here. 6x cubed minus 6x cubed, 0. 11x squared minus a negative 4x squared will be 15x squared. Bring down the minus 31x. 3x times what would give me a 15x squared? That would be a 5x, so plus 5x. Multiplying 5x by 3x gives me a 15x squared. 5x times minus 2 is minus 10x. And subtracting. 15 minus 15 is 0. Negative 31 minus negative 10. That's negative 31 plus 10. So minus 21x. Minus 21x. And then we'll bring down our 15. Alright, now 3x times minus 7 will give me minus 21x. So negative 7 times 3x is minus 21x. Minus 7 times minus 2 is plus 14. Subtracting those, minus 21 minus negative 21, 0. 15 minus 14 is 1. Now, I can't divide any further, so this is my remainder. That is my remainder. Well, I write that as r of x, but really that's just my remainder. How I'm going to write this is my remainder divided by my divisor, so 3x minus 2. So my full answer is this expression right here. That is my answer. Now I'm going to write this in division algorithm form. This would be my original function plus 11, and this is that f of x equals d of x, q of x plus r of x minus 31x plus 15 equals my divisor times my quotient. My quotient is the 2x squared plus 5x minus 7 plus my remainder. In this case, my remainder is 1. You can verify that by multiplying it out, but that answer from our long division is coming from this fact. The fact that you could write this as the product of these two plus 1 is why we have the quotient plus our remainder over our divisor. All right, keep that in mind. We're looking for the big picture here. Okay, that's the thing. We want to notice what's actually going on. Now, long division works all the time. Anytime you're dividing two polynomials, it will work as long as that you're dividing by something of a lesser degree. Synthetic division is a shortcut that we often use, and it will come in handy a few times in this next chapter, okay, as we're going through this chapter. However, this is a shortcut. Okay? Long division always works. So if you have an issue with synthetic division, if something is not working quite right, then go back to long division. Okay? I don't like teaching a trick here. However, it does make our division go much quicker when it works. Okay? And it works whenever we have something of this form, x minus k. Okay, x minus k. So if our factor, so here each one of these we have x minus 3, then in 4 we have x plus 2. The next one we have an x minus 1. Things work out very nicely with those. But it only works when we have those linear factors. Okay, so follow what I'm doing, but the most important part of this is actually the long division, the idea that division algorithm works. So what we're going to do is take our coefficients from this. We're going to write these down. So 5, and I'm going to go ahead and label it as an x squared up here, so I remember that. Minus 3x, minus 36, and those are my constants. All right, now what I'm going to divide by is actually the value that makes this factor 0. So in this case, x equals 3 is what makes that 0, so what I'm going to put over here is 3. Alright, so we'll first bring down the 5. This is the way, actually, if you look at our long division side by side with this, you'll see why this actually works. Bring down the 5. Now we'll do 3 times 5. 3 times 5, which is 15. Bring a 15 here. We will add. Okay, we add going down, and we multiply by that 3 as we go. Adding those, we get 12. 3 times 12 is 36. Adding those two gets us a 0. So the answer from our division, okay, is 5x plus 12 with a remainder of 0. All right, so I'm going to go ahead and write out what this means. 5x squared minus 3x minus 36 divided by x minus 3 is equal to 5x plus 12. Division algorithm form would show us this one actually factors because we have a remainder of 0. We can see that. Our divisor times our quotient. Plus 0. So the solution when we say divide these is the quotient. That is our quotient. However, the division algorithm is very important with seeing what's going on. All right, we'll go ahead and do the same with this next question. 4x cubed plus 10x squared minus 6 minus 20. We're dividing that by x plus 2. All right, so that's an x cubed. Oh, notice we're dividing by a linear factor here. So the degree always goes down by 1 because we're dividing by a linear factor. So an x squared divided by an x term, which should be an x term, which is why I have the 5x there. That's an important thing to note. All right. The degree always goes down by 1 with synthetic division. So 4x cubed plus 10x squared minus 6x minus 20. That is my constant. This is x plus 2. So the value that makes this 0 is negative 2. So I'm going to put a negative 2 here. Now we'll bring down the 4. Negative 2 times 4 is negative 8. Adding those together, we get 2. Negative 2 times 2 is negative 4. Negative 6 minus 4, or plus a negative 4, is minus 10. Negative 2 times negative 10 is positive 20. Negative 20 plus 20 is 0. So this, again, divides evenly. This divides evenly. And our solution is 4x squared plus 2x minus 10. And again, written in our division algorithm form, that would be that 4x cubed plus 10x squared minus 6x minus 20 equals our divisor, x plus 2, times our quotient, 4x squared plus x, plus 2x. Okay. Plus 0. Our divisor multiplied by our quotient, adding our remainder. So that factors in that way. It actually could factor a little bit more if you notice. So often synthetic division or long division is our first step in the factoring process. Alright, let's look at example 5. Alright, so I have minus 9, x to the 4th, and I actually label these for a reason, because we have to make sure we have all of our degrees. So our highest degree here is 4, and we're decreasing. So I should have a 4, 3, 2, 1, and 0, which is our constant. So 10x cubed, 7x squared. We have a minus 6, that's our constant, and then we do not have any x terms in there, so I'll leave a 0 there as a placeholder. And then this means x equals 1. Alright, bringing down our minus 9. 1 times negative 9 is negative 9. 10 minus 9 is 1. 1 times 1 is 1. 7 plus 1 is 8. 8 times 1 is 8. 0 plus 8 is 8. 1 times 8 is 8. Negative 6 plus 8 is 2. Alright, so my solution to this is minus 9x cubed plus x squared plus 8x plus 8 plus 2 divided by our divisor, the x minus 1. And that is my division. That's the result when you divide that. So you can see that this actually has, well, we'll see in a future section, this actually has an asymptote, but it also, no it doesn't. Okay, just it has an asymptote of a cubic function actually. Alright, our last question in this section. The volume of a rectangular solid is given by this polynomial, 3x to the fourth minus 3x cubed minus 33x squared plus 54x. And it says find the length of the solid given by 3x, or the length of the solid is given by 3x, and the width is given by x minus 2. Find the height of the solid. Alright, so what we're actually trying to do, okay, we have volume equals length times width, and they're actually using t for height. I'm going to keep an h there. So rearranging that, what we're actually trying to find is height. So our height is volume divided by length times width. We're actually going to perform two divisions. We're going to start with our volume. (3x to the fourth minus 3x cubed minus 33x squared plus 54x. Now, if you recall our factoring, this actually has a greatest common factor. I'm going to go ahead and factor this. A 3x is our common factor. So that leaves us with an x cubed minus x squared minus 11x. That should be 54 right there. Plus, that is an 18. If you notice, 3x is the length here. So what we've just done is divide by the length. So next what we want to do is divide. Okay, so this, what we have left, is the width times the height. So we need to divide this by the width. This is where our synthetic division will come in because we're dividing by x minus 2. So that makes an x equals 2. Putting our coefficients here, 1x cubed minus 1x squared minus 11x, and our 18 is our constant. Bringing our 1 down, 2 times 1 is 2, negative 1 plus 2 is 1, 2 times 1 is 2, 2 plus negative 11 is negative 9, 2 times minus 9 is minus 18, 18 plus minus 18 is 0. Alright, and so this actually factors, again, x minus 2 goes in evenly, as we just saw, with a remainder of x squared plus x minus 9. So this was our volume. And we have our length times our given width times our height. So find the height, and they tell us to use t there, equals x squared plus x minus 9. So division can actually help us factor much quicker in lots of cases. Alright, that's the end of this section. So review long division because it always works, and synthetic division because there are some cases where it will come in very handy. So be familiar with both of these.